Okay, I seem to be live. Perfect. Hello, everyone. Welcome back to the stream. Sorry I missed the stream last Thursday. I was working on a small other project and I completely forgot that it was time to stream until it was way too late. I've finally uploaded all of May's videos on YouTube. The channel with the backlog has everything now, except for, I think, last week's stream, but that's about it. Otherwise, everything has been uploaded. Last week, we made quite a lot of progress on the analysis. I only streamed Tuesday because, again, sorry, I missed Thursday. But last Tuesday, we finally started tackling functions, and there's going to be a lot of work. And I think all of this evening is going to be more analysis of functions. And I don't know how much progress we'll make, but I guess, yeah, that's the program for the upcoming, for the foreseeable future. So, yeah. I don't think I have any other announcement or anything. Again, the YouTube is almost up to date, and yeah, let's get started. So, last time we finished with a very rough draft that compiles, but that's about what all we can say about it, of this function here, analyze function expression. Because we are doing this analysis phase where we take the past version of our code and we're doing name checking, type resolution, like basically all of the checking of what the user gave us. Past that point, we must have resolved everything, even though we will keep the code in the same shape. We will not do deep transformation of the code beyond possibly some optimizations like constant unfolding, but beyond that, we're not going to do much. So we're keeping the same shape of the code, but we need to make sure that past that point, nothing can fail from the user's perspective. Like, we might have bugs in our code, but this phase is the last phase where we're going to report errors to the user. So we analyze a function by analyzing the return type, making sure it matches with it is a type we know about. We check the type parameters, we check the arguments, and then finally we have to check all of the statements. Checking the statement is this simple switch case here of well, did we encounter a continue? Did we encounter a break? Did we encounter the return statement? What did we encounter? How do we analyze that? For some of this, there is not much to do at this point because, again, at this point we were just doing name resolving and type checking. They're very basic checks. So for continue statement and break statements, the only thing we have to do at that phase is, are we in a loop? Is this correct syntax? Is it meaningful? Is something that at this stage we don't really care about. We will have, during the lowering into IR, a phase during which we do all of the control flow analysis, where we will be able to say oh, this actually never runs, or we can simplify away, but at this stage, that's not what we're doing. So for now, continue statement, break statement, fairly straightforward to analyze. But I started doing return statements with the idea of, oh, that's going to be one of the small ones compared to the if block or anything. But no, it requires evaluating an expression. And as soon as we require evaluating expressions, things get complicated. So we started working on this. Do the function there, analyze function expression. We have a expression in the context of a function. Is it valid? Let's analyze it. And that is going to be an absolutely gigantic switch case of all the possible kinds of expressions that we may encounter. And for each of them, well, yeah, what do we do? How do we deal with this? Last time we did cast, and we didn't even finish it. How do we analyze a cast? And there are only a few things we can do. If we know that we are casting from enum to enum, again, if we know the value we're casting at compile time, then we can do compile time checks. Is this value valid as a cast? Can we perform the cast? Perfect. We replace the full cast by the new resulting value, like we do for constants, where all of the constant values are evaluated at compile time. Otherwise, if it has to be done at runtime, then for now we've left a to-do. The reason for this is not all casts will succeed, and we will probably want to have something at runtime that'll be able to say, actually, this is not valid and crash otherwise. Some languages do that on debug and on release, but we might want to do something like this, and I was therefore wondering if we wanted to do that at this stage. At this stage, do we do the analysis and translate that cast that has to remain because it involves dynamic values into something like maybe a function call. Like maybe we replace the cast to a function call, to a built-in function that does the cast and is already like defined somewhere else. And I am erring at the moment on the side of not doing that because function calls will be expensive in our target language. And instead, I think it will be during the code generation phase where a simple cast, which is basically a no-op, a cast is like purely for the type checker and therefore meaningless while we actually generate the assembly, quote unquote. I think during this code generation, we will still have information about the type at that point, and we will be able to like replace not with a no-op, but actually with a check that like, oh, if this value is out of bounds, panic. So I think, as a result, those insert runtime cast things here can be simply the result of the analysis is a cast. This is going to be a cast, and we can just emit the cast with the resolved parameters. I'm going to do the same thing I did last time, which is I'm going to do this and open the AST here so that I can have a look at what I have. What's a cast expression? It has an annotated expression, which will be a typed expression, which is the argument, and a type. Oh, the path to a type. So if we look at this function, so this case here that we didn't do is we're going through a enum to an enum, which is a fairly easy cast to make because enums are just like a subset of int, basically. And here we're just trying to see, do we have a value known at compile time, in which case we can just inline it. Otherwise, we don't. This is going to need to be a cast. And I suppose that in most of those cases, the result cast is something we can cache because it's always going to be the same. When we cannot compute the cast at compile time, but we think it's valid given what we know at the moment, it should be a cast expression with the resolved expression and the resolved. Let me just check whether this is urgent. Not urgent. And a resolved target type is what we have here. Which means that in all the places where we don't have enough information to do the cast at compile time, but we know it's valid given the information we have, then we are going to be able to just say, well, that's the result cast. Here we don't have to do any further type checking. Enums will always be compatible from one to the other in terms of like type checking the validity of this. The value might not, but the cast is valid. Here we're converting from an enum to an int that's valid. We can therefore likewise, I can even just insert the result cast. Does it make sense to convert a character, to cast a character type into an enum? What do we do for constants? Do we allow cast from character to enum? I think we do. Maybe we shouldn't. If I look at expressions here for constants, we seem to be allowing cast from character to enum, but we are rejecting. No, that's wrong. Sorry, no. We allow from enum to character. That feels like it's probably not very useful, but at the same time, I don't think it's ill-defined either. In the sense where, like, for a character to be useful, it would be like it would need to be the 30th or so character, like value in the enum in the first place, and that doesn't seem super common. But at the same time, I see no reason not to allow it in the first place. So, sure, let's have it. And an enum into a boolean would be basically it's not 0, it's not the first element. That's fine. Which is kind of how like a boolean can be implemented at times, so that's not absurd. If it's void type, it always succeeds. Isn't that the same thing as the result cast? I think it well might be. I think it is, yes. So I can remove this. Except I'm using something called value, and where is that value coming from? It is the expression value here, which is part of what I'm giving here. Okay. And how was this created before I changed it? Typed expression, void type value. Yeah, I think that is correct. But that happens to be the same thing as this, I think. Oh, wait, no. It is not. This was different. This is the cast being done. The cast has been removed. The value as it is a valid value of that type, regardless of what it is, because this is the well, not regardless of what it is, but because this is the void type. This is a special type that users don't have access to, which is the type of a panic. What that means is like whatever that thing is, it has panicked, guaranteed, which means the cast is irrelevant. We can just surface that as like, yeah, we have something of type void here. We have a panic, and therefore everything that's on the branch can just from that point ignore everything else because this has panicked, guaranteed. Okay. I think this is incorrect. Unless this is used not in the way, no, I think this is incorrect. Because what this does here is in the case where the type that we're casting to, no, the type that we have as of the expression that we are casting that we have resolved, if that type is a type parameter of the function, because we have generic functions, then what I'm saying is skip the cast for now. We cannot analyze this function at this juncture because I'm doing the C++ approach to type resolution, basically no trait, no nothing like this. We will check the validity of the types whenever the function is instantiated. If that function is instantiated with the parameter t being int, we'll go through the type checking and check that everything is fine with t being int, and so on and so forth. And there will be a different copy of the function in memory per type of argument. What that means is if I have something of type parameter, well, at this point, all of my type checking has to succeed because it will depend on what the value is. For now, there's no reason to reject it. So, I think this is correct, except I'm not sending the resolved expression. I don't think that's true. I think I'm sending the result cast. I keep the cast. Because the cast will have to be analyzed again when I know what the type argument is. The type argument is, yeah, type parameter, sorry. Until I do, and otherwise, any other cast is just simply not allowed. We can report an error. So here, this is the cast no longer from, this was from value to an enum. This is from something that we have resolved to be an enum. So I have value that is an enum into something else. I don't think this is correct. I think this is the same problem where. No, actually, this is fine. The cast here can be removed because a cast from enum to int cannot fail. So that means that if the value is correctly constructed, the cast cannot fail. I can remove the cast altogether. It will be a no-op when we reach code generation. So I think. Except I think this is wrong. What this is saying, this case here is saying, oh, the value we had, we identified that the expression in the cast, that one that isn't an argument, is of type character. And we know from the match we are in. Sorry, no, target type. I'm saying nonsense. We are casting to character, and we know that the value we had as an argument is an enum. Either we already have the enum value at constant time, which will have been checked by that point, and therefore we can, in all likelihood, assume is correct. Casting to character, just like casting to int, will always succeed, or we don't have yet a runtime value, but it's always going to succeed anyway. So I think here we can afford to remove the cast explicitly, unless some transformation needs to happen at runtime. I don't think so. One such example of something that might happen, it might be possible that I expect all values of type Boolean to always be 1 or 0, which means the cast to Boolean would have to reset the current value to 1 or 0. In which case, it is not just removing the cast and saying, yeah, from this point this value is a Boolean. I would also need to probably simplify the actual value underneath. No, I think this is correct. I think at this point, those casts cannot fail. And finally, we have this gigantic nonsense. There is no enum there. Those are all casts that are going between int, boolean, character. None of those can fail. The types are known. Therefore, all of them, the cast can be removed. However, I think there's a mistake there. And here, and possibly, no, this one is fine. The problem is I don't handle the case of the type parameter correctly in all cases. In this case, from enum to enum, it is irrelevant, I think. Hmm. I should get into the habit of thinking out loud, so you just don't get a stream of me looking at my stream with my eyes closed and just not saying anything. Yeah, we need to make sure we handle the case of the cast from and to type parameter, because those are not done at this point, which means in those cases I cannot remove the cast, it has to be kept. And so I think we have to do the same thing here. I'm gonna copy and paste this. This is incorrect because I am testing whether the target value is but at this point I have already resolved the target value. I know it's an enum, so that makes no sense. So this has to be, sorry, I'm tired this evening. This has to be not the resolve expression. This has to be the target, the resolve target type. If indeed we are casting to a type parameter value that we don't know yet at this point, is that necessarily true? Yes, because if the type parameter applies within the parameter of something else, we don't support that. For instance, we support casting from int to character, but if we have vectors, we don't support casting from vector of ints to vector of characters. So the only kind of cast where a type parameter would be relevant is if it is the top level. So this check should be correct. Next, here I think we have the same problem, but we have to handle it. We have to handle both cases. Which means I think here I have to check for both. Because now, armed with both, if the first one is a type parameter, if the value I'm casting from happens to be parameterized by the type of our function, there is nothing I can do at this point. It doesn't matter what a second type is. This is a pure of the result cast. In the case where the first argument is not a type parameter, therefore the type of the sub-expression is not the value, a type of a type parameter, but something else, but we're still targeting a type parameter. Likewise, we can't resolve this at this point. Anything else is a cast between two random values that are not type parameters, therefore known at this stage, or at least somewhat partially known, and there is no such thing as a cast on any of this that might succeed, therefore cast error. Okay, so let's compile that. I might just like take a 2-minute break to go open a window or something. Yes, this is not aligned properly. This should be this. Probably the same thing here, I suppose. Oh, yes, of course. The resolved version is not just the expression, it is the typed expression that therefore also contains a type name, which happens to be resolved target type. So this is a path info, which is already the type, so I can remove this here. Is it just a matter of... Yes. Why do I have two path names here? Something is wrong. Something is wrong, because here this is the path name of the resolved target type. When we start from an enum, otherwise this is the path name of the expression type resolved exp. Oh, is it just a matter of... Okay. I think it is something like this. Let's see. The compiler is happy. I'm gonna align it here for readability. So I'm guessing that path name is not accurate on the path info then? That seems surprising. Wait, is it just that the resolve target type is not what I think it is? It is just a resolve type. Ah, so it is a path info. Ah, but therefore there is no expression type. This is not a type expression. There we go. Getting closer. Okay. Okay, since that compiles, I'm gonna take like 2 minutes break, just like open a window, just get some fresh air. Be right back. Okay, let's get back into it. Sorry about that. So, I think at this point we're done with cast. That should be all that we need for cast of an expression. Which means we can move on to the next step, which is going to be this thing that we have commented out here, which is going to be a path expression. So a path expression is not going to be any random path to another thing in the program. It's going to be specifically a variable name, constant name, something like this. We don't do function types, therefore function as arguments should not be valid. So here I should be able to resolve this always to something that has a value of a type that is not a function. However, this is also where I'm going to need to be able to resolve variables, because we might encounter variable declarations. There are going to be arguments to the function which are already added as part of. How did we add variable arguments already? I think okay. So we put them in a separate part of the context which I might change to instead be all of the variables, because there's no reason to treat the arguments like in a very specific way. Any name that is declared with the function serves the same purpose. So I think I'm going to go back and look at the monad. And we have here this function no, okay. There's a reason the function arguments are treated specially. That's because some of them will be references, which means they are going to be able to modify things in place. The value that are being assigned to them will like persist beyond the function. Does that mean I can reuse this for variables, except they would all be non-references, I guess? And most importantly, how do I store? Because I need to know do I need to know where I need to scope the variables. I need to associate them with a current scope. That means that when I exit a bunch of statements, when I exit a bunch, like a block of statements, I need to remove all the variables that were declared within, because suddenly they no longer exist. So I am going to need to have something. I have changed a lot of the stack approach using reader to the monadic context I'm keeping throughout the function. I think I'm going to have to make a change, which is that here in the analysis I have this analyze statement, and I think it is just called by doing a traverse of the analyze statement, and I don't think that's correct. I think I'm going to need a separate function for an analyze block that will take a full block and do some of the maintenance of the scope, namely what variables are in that scope. And then pop that scope on the way down. Does that mean does that mean that I do simply like keep a stack of scopes, and whenever I try to find a variable, I go through all of the scopes down by one? Or does that mean simply that whenever I create a new scope, I clone the previous one and then do modifications to it, so I can just pop it at the end when I'm done? That second approach might be easier. Okay. So this is gonna be, go back here to have a bit more space. If I look at what a block is, I don't think block is a type, but a block is always a list of annotated statements. Okay. I had a moment of like, is it a non-empty list? But no, a block of statements can be empty. Just check this. I will answer after this. So those are going to be, I don't have to use the annotated. I can already, actually, I've zoomed out slightly for convenience because those are big functions. Let me know if it's too small and I'll zoom back in. So this takes a bunch of statements and this will return as everything else within our analysis monad, the same thing, but resolved. And statements lose their location in the resolved version because we don't need to keep track of location past that point, because past that point there will no longer be error messages that are based on a mistake on the user side. Okay. The core of it will still be the same thing here. Where is it? Traverse. Here. That is still gonna be the core of it. But this is now an analyze block. And this at the core will be a traverse analyze statement of the statement. However, here we can now do some of the scope thing. The only thing I wonder is if I want to annotate, because I don't do the control flow analysis at that point. This will be done at a later point. The control flow analysis will basically translate every function into a graph of blocks from which, like, that are linked by statements like jump or just fall through, basically. Do I want to try to keep track at this stage of where each variable is created so that when I do the translation into the IR, rather than knowing, oh, it is the variable foo that's in scope, I can say it's the one that was created to scopes above? And I think not yet, at least. So I think here, I think here, I don't need to keep the full stack, actually. I can just keep a copy of what the stack was before the block and just restore that at the end of the block. That's probably easier. And I don't need to change the declarations because nothing in the block will create new declarations. The only thing it will introduce is new names. And I think that's about it. So that means that I don't even need to do anything complicated stack-wise. I get the previous scope that was there before we entered this block. We traverse all of those statements, manipulating the scope as we go, adding variables if new ones are declared, and so on, shadowing previous ones, whatever. And when we're done, so that's our result, we simply restore the previous scope. And we return the result. Okay. That means now we should have variables in scope. Do I need to... The thing about the function arguments is I need them because at the code generation time, I will need to know whether I write their values into a discarded part of the stack that gets erased when the function returns, or I write their values to a part of the stack that is preserved when the function returns. But that's something that I only care about during code generation. This is something I only care about during code generation. Hello, how are you? A bit tired, but making slow progress on the analysis of statements. I was thinking out loud at the moment about the way to do scoping. What I have introduced is a very simple function here. Where is it? Right there, analyze block, to basically, I'm going to go through a block, therefore I'm going to have a new context, a new scope, a new bunch of new variables, a bunch of new names. Since I am no longer using the reader monad that can do the stacking for me, I have to remember this was the state before I go recursively through all of this. This is the state, I restore that state when I'm back, so that when I pop out of this block back to the calling context, what was declared within it falls out of scope. I don't have to worry about destructors or anything like this. It's just the names are gone from the context from this particular thing. Now, with that done, I should be able, when a new variable is declared, to just add it to the current scope. What I'm wondering about is, should I maintain this thing I have done last time, where I maintain a special hash map for variables, for function arguments, because function arguments are the only place in the language where references are allowed, and that's to be able to mutate things in place rather than assigning results of a function call. I want to have that because I think it's interesting to have, although it's a bit more difficult, but again, it would be too easy and not fun otherwise. And I wonder if I can instead, rather than keeping this separate hash map for the variables that when I do variable resolution, know where to point, I think I should not do that. I think instead I should look at name. And I think here, when something is a function argument, I should include its type. I think I should include its type because I will know the type of variables. Yeah, I think it's the easiest thing to do. At this point is like, okay, this in this scope, the name foo means this variable that happens to be a reference, or it means it happens to be passed by copy, which will be useful information at the time of code generation. Yeah, I think this is the proper approach, and therefore, do I have let bindings? I do believe I do. So this would be something along those lines, except this is just a normal type, which is a path info resolved, if I remember correctly. Do I have let? Let's look at statements. Well, I could look at the AST for this actually. Rather than looking at the parser, if I look at statement, where are you statement? I do have let statements. Okay. And I think I've modeled this after Rust, so rather than having the let statement contain... No, I do seem to have a let info there. No, I do pass the identifier. Interesting. I thought I had the thing where I had the assignment operator be a valid operator, but it seems I don't. Well, no, I do have an assignment expression. So what is the difference between let then and... I guess every assignment can be done... Well, let declares a new variable, the assignment is just assigned a new one. I guess it's just... Yeah, I guess that's it. I'll have to check whether... Yeah, no, I think that makes sense. Okay. And so I will always have the type... Yeah, I think, okay. Okay. So, to go back to here, I'm going to remove the fun args of this, which was here, so that removes one empty map from here, which means we go back to the top of our function analysis. And here, resolve arguments. I have that thing where the context is fully reset before each function call, so I can modify the global scope at this point for the function because arguments are global to the function, therefore it's fine. And that means here, I suppose, rather than adding it to this, the function arguments. Oh, I was already adding it to the context names. Okay. But that just means I can remove this and change how resolved name is declared, because now it contains the resolved type. There we go. That means that to go back to analysis of the expression in a function, I can now write this resolve value. So I have encountered the name of something in an expression. It is not a call expression, it's not an array indexing expression, it's not any of those things, so it is just straight up a name. So that thing needs to evaluate to something that can be part of an expression, so it needs to be some kind of value. It can't be a function because we don't have function types. It must therefore be a function argument, a local variable, a constant. I think that's about it. So let's write resolve value. I have all of those resolve values everywhere. Let's do resolve const value. And let's change it to resolve value. Do I allow placeholder as part of this? It makes no sense one way or the other. Values do not... actually, wait, that's not true. That's not true. Could a value have type parameters? No, because constants cannot have type parameters. Variables cannot. Arguments cannot. Therefore, there isn't ever gonna be... The path there will point to something that doesn't take type arguments. I can allow placeholder, it doesn't matter anyway. Okay. Okay. So when we find this is also something I am going to have to change. There is a bunch of places where if I assume that if there's no declaration associated with something, then it must be built in. That's not necessarily true. So what do I have access to in this resolve callback? I have the resolve path, which basically is the type. Well, not the type, but oh, hello again. Thank you so much. I'm still doing the analysis phase of the language. I haven't moved past it yet because it is taking a long time. So at the moment, still looking at the past version of the language and doing all the name checking, type checking, and so on to check that everything is fine. So at the moment, I am doing the thing of like, I have found a variable name in a expression in a function. Is that valid? Look at all the names in the context and decide based on that if it's valid or not. What I'm trying to decide is here. So I have the type of whatever was resolved. Well, that's not true. I have the path, which is not the same thing as the type. I would need to have access to the name. And I don't think my callback actually at this point gives me the name of the thing that has been resolved. Because resolve path looks at the name, but tries to then call resolve name. And if wait, am I am tired. I am wrong here. If I go to path info, yes, this is gonna be the name. Yes, the path is going to be replaced by the name after resolving. I am wrong. Okay, that's perfect. That means that here, when I do resolve value, this thing here contains the resolved name of the thing that I was pointing to, and optionally, its declaration. Not everything will have a declaration, because not everything will have been declared at top level of a module. So I can look in the case here where this is not, so a type alias would be wrong if someone tries to do t plus 3 and t happens to be a type alias, not a variable. That's not correct. Likewise for a function declaration, for a struct declaration, all of this is not a value, an error that doesn't exist yet, but let's create it. If it's an enum, if the thing we found points to an enum, that doesn't mean that it is the enum. We need to check. Yeah, there we go. If the identifier is the enum name, then we are pointing to. Wait, no, I should be looking at the resolved path. This is the wrong way to do this, because if someone makes an alias, it's going to be wrong. So no, I think this is wrong here. I should be looking at the name. Except what name do I use for enums? No, because that's the whole point. I use the name. Huh. Because what I'm doing here is basically in my scope, I have all of the names of things that are accessible from where I am. I will have the name of the enum because that's a valid type in my scope, and I will have the name of the different values of the enum. To be able to identify them, I have those names point back to the declaration of the enum itself. So when I find something that happens to have a declaration which is that's an enum, I need to distinguish between is that the top level thing or is that an alias to it. What I'm doing here is I'm looking at the path to the thing I found, and I am looking at whether it is the name of the enum. I think that's correct because the only way it would not be is with the type alias that renames the enum, but that would have been resolved by now. I would have. No, I am looking at the original path. It would not be resolved. So I would be seeing if someone does a type alias t equals some enum, I would be seeing, oh, this is t, which is not the name of the enum in a declaration. Therefore, it is one of the values. I think I have to do it the other way around. Since new values cannot be if my assertion that all of the values that point to that enum in the scope will always be either the type or one of the constants. The constants can be of the values of the enum. The values of the enum can be bound to a constant, but they will be the same. Because it would point to a constant in this case, or it would point to a variable. So if I'm pointing to the actual declaration, it means I'm targeting the actual value of the enum. And rather than being like, oh, is this identifier the thing? I think I can safely assume that if it is not one of the values, then it is the type. Is that sound? Can I conceive of a situation where the wrong name, where a path points to an enum that is neither the type nor... I don't think so. I don't think so. Yeah, because if it's the case of a type alias, I would first point to the type alias and be like, oh, whatever it's pointing to, it's a type, which isn't what I'm looking for. So I think this holds actually. I think this is fine. So I can keep it that way. If the original path pointed us to an enum without the layer of indirection of a type alias, and it has the same name as the enum, that's the enum type, not a value. Otherwise, we look at what the index of that thing is. If we don't find it, that's an internal compiler error. Something in the reasoning I've more or less explained out loud was wrong. We need to panic. We will have proper errors at some point. This is a crash that is bad, but at some point we will have something a bit cleaner than that. And in the case where we do found the value in the enum, that is a valid thing. Can we just replace it immediately? Can I inline this? Like, oh, this path points to whatever is in there. I think so. I think in this case, because I'm returning a typed expression. So I'm returning something that's like whatever this thing is to be evaluated at runtime. But if I know at this stage, because I'm pointing to an enum, yeah, it can just be a typed expression. Yeah, I think this doesn't change. Okay. And here I think it's the same thing. If I found that in my expression within the function I'm doing foo plus 3 and foo happens to be a constant that I have access to, constant being resolved at compile time, it will already have been resolved by that point, meaning, well, or worst case, it will have been resolved after this, basically. And that means I can substitute that constant by its expression in my function, because constants cannot have side effects. They are compile time values. So that's fine too. So we have handled all of the cases where we do have a declaration associated with the name. Now we need to handle the cases where we don't. And now I'm no longer going to be in the case where I am no longer going to be in a case where I can assume that the only thing that doesn't have a declaration is a built-in. That's no longer true. This was true, I think, for almost everything so far, but that's no longer the case. And I might have to go revisit some of my previous functions for the resolve that make the same assumption, because I think that is no longer true. I think in this case, I have to look at the name. What kind of thing am I pointing at? So that would be case of the path name. Let's have a look at what kind of names this can be. If it's a top level declaration, it should have an associated declaration. We didn't find one. Internal compiler error. We can handle this later. That's not supposed to happen. Built-in identifier. Built-in type. Built-in type is a possibility. It would be wrong, but that's not a panic. It means someone has tried to say int plus 3, and the only thing called int in scope is the type int. And therefore, that's an error. For a built-in function, that's going to be the same, I believe. To the point that I could almost bundle those cases together, because it's going to be the exact same case. A type parameter, is that possible within the scope? Yes, because functions have type parameters. So we are in the context of a function that has a type parameter named item or something, and someone does item plus 3. That item, the only thing in scope is the type parameter. Therefore, we end up here because there's no declaration associated with it. That's not a fatal error. That's not an error on our side. That's an error on the user side. They've tried to call a type parameter. Which is going to be the same. So I think I'm just going to group all of the default case as like, none of this is a thing we can handle. Reword error. Placeholder. Can we find placeholder as a name? If we do find placeholder as a name, does that mean I don't think that's a possibility, is it? Aha, here I am making... No, it's fine. I'm not making too big of an assumption. Now, however, could I encounter a placeholder in the context of this? What does that mean? It means I'm trying to resolve the name, and I found an underscore. I think I have said allow placeholder. Maybe that doesn't make sense because I am inlining. Haha, I need to be careful. Yes, a placeholder doesn't make sense in here. I am not in a function call. I am not in a anything else that could have type parameters. I am finding something that must be a value, therefore a variable, an argument, or a constant. Its type might have some type arguments, but the path does not. The name does not. That doesn't mean they can't happen, but that means if there are some, they're wrong. What that means. Oh, actually, I should check. I should check in several of those. I don't check that there's no type arguments. Like here for the result constant values, if I'm trying to call something that is a constant and I give it type parameters, not gonna be rejected. I need to check that. Okay, so same here. So can I have found placeholder? And I think the answer is yes, because I I have not validated yet by that point that the name that was given to me was not a type instead of being a value. Which means at this point, if the name of the thing that was given to me is just underscore, and there is nothing named underscore in scope, which I probably won't allow in the first place, then this will resolve to placeholder. It will resolve to the type name placeholder. Do I prefer this to fail like, hey, found placeholder, that's wrong, or do I want to here give a better error message because I have matched that thing as placeholder, which is a type which I know is wrong, and therefore I am in the middle of resolving something and I can give a better error message and like that's a placeholder that's not expected within this context. Also depends. I am saying allow placeholder to resolve path. And I guess underscore must be already always in the context, probably because it's a built-in. Yeah. Okay, so this always succeeds. So that probably means yeah, I do the resolving of placeholder as part of this part of resolve type, which would not have been done by now. So, okay. I am going to here, I can get a placeholder. That's a thing that might happen. And I will need to. Do I need a special value like error for this? Or can I just say, hey, I was trying to find value, did not find the value in scope for that name? Well, the thing is, we will find a name for that in scope, so maybe here I should do a report error. What did I do for report type? Error placeholder context. Here, context is something I can just specify myself. Yeah. Function, expression, path, something like this. Not great, but that's better than nothing. That's the base case. I want to handle top level declarations specifically because that means we have something that's supposed to be a top level declarations, but we did not find a declaration associated with it. That's definitely an internal compiler error. And we're left with two of them, a function argument or a let variable. So function argument or variable introduced within the function. And I think at this point, I don't have to do anything. I have found where the value comes from. That's a variable or an argument in scope. The type will only be checked in relation to other parts of the expression. I'm calling a variable of type int. Sure, that's a variable of type int. Whether int is correct for the context depends on how it's used. Therefore, I think that in both of those cases, the result is just going to be a typed expression where the type name I can't give a function archetype there. Let me check something. This is replaced by a path info. Perfect. That means it's basically replaced by the name. That's perfect. That means... do I have the type of this? I need to extract the type out of this. And the value will be the resolved path. It will be a path expression. Yes, I think that is more or less correct with the distinction of this being here at the bottom. And I'm going to move those two at the top because they are the normal case. Here for a variable, it's even easier because the type is already there. I don't need to do the name, I don't care. Var type, this is what it is here. This is a typed expression. This variable call is replaced by a typed expression because I annotate the result of resolving the expressions with their type with the type of the variable I found in the case of a let, and a value which is the same thing. I don't do any inlining or anything like this. Could I do inlining? Could I do inlining? Could I do that at this point? I could perhaps do that, but maybe I could do that later. Basically, like, is the value of this variable known at compilation time when I'm doing the analysis here? If yes, could I inline? Oh, I need to be careful. I need to be extremely careful. I would have the value at time of initialization. And unless I have a way to label every time within a block a variable can be modified, then using the value at constant time, well, at compile time, might be completely wrong. So I should not do that kind of optimizations now. This might not be a bad place to do it at some point, but I shouldn't do it at right now as I'm still developing this phase, especially on an evening where I'm tired and I'm not thinking completely correctly. Okay, so no, let's not try to do inlining there. I have found that this points to a variable. I am perfectly happy saying, hey, that's an expression of type whatever the type of that variable is, because that will not change. And the expression is the same. It is a path expression that points to that specific variable. Okay. And for function arguments, it's going to be the same with the distinction that I have to extract whatever the type of this thing is. And I might, for function argument type, I have a typo, which is when my search isn't working. I don't seem to have a function that does that, interestingly. Huh. Oh, no, I do. Well, no, that's in the parser. I don't have a function that does that. Interesting, okay. I guess it's because it's trivial to do anyway. So that's the name of the argument. I do not care about it for this part. And that is the function archetype. I could almost decompose it here. This is a by value, and that's the type. And that's by reference. Is that what they're called? That's what they're called. Okay, so that should be it for resolving a value. I am worried that I might have to go back. Excuse me. For instance, in a constant, what can I find that is not, that doesn't have a declaration? If I go back to my list of names, can't be a top level declaration, could be a built-in type or built-in function, neither of which is correct. A type parameter, no. A placeholder, no. A function argument, no. Or a letter variable identifier, no. So I think even though a better error message would be important, this is fine. We don't need to do the distinction here. And here I accept anything that is not a placeholder when placeholders are forbidden. I should probably also forbid things that are values when I'm trying to resolve a type. Like, hey, is this name I have found a type in the current context? For instance, I'm doing a cast in an expression within the function. Hey, I'm casting to foo. What is foo in this context? If I find something that doesn't have a declaration, if I find something that doesn't have a declaration, it means it's either built in or an argument, I guess, or a variable. Can it be anything but I still think, yeah, no, I have to handle this. I have to handle, because if it's double declarations, we have already encountered it through another mean. Placeholder we're handling. Type parameter, however, we're handling kind of by default. So I think, yeah, I just need to reject function argument and let variable. Okay, I think that's correct. All of the others are fine. Placeholder is not fine if we don't allow placeholders in the current context. If we encounter a function of a let variable, that's not a type. Okay. Okay, I think this should be fine. Therefore, we can go back to resolve function. Sorry, to analyze function expression. And I can, yep, that should be fine. That should be resolving a value. Let's try to compile this. Given that I am not doing super well, I might stop when this works. We'll see. Okay. Function archetype is something that doesn't exist in this context. That's why I was doing the peculiar thing where I had in my monad here a hash map from function name to the function archetype. And that is because I am here introducing a circular dependency between the AST and the name. AST is aware of name because the resolved version of the AST uses a name parameter. Also, although I guess I could I might be able to handle this without circular dependencies. Where's the only place where name happens? It's here, I think. So otherwise, it is all name type. So could I separate the modules? The problem if I separate them is that I would make the instance of annotation orphan. The AST needs to know about the annotation because that's the whole key of it. Therefore, it needs to know about AST phase, which means that doing the instance for them outside of this module would not work. And therefore, I have a circular dependency. Okay. That's fine. It's been a while. What's the proper syntax again? Is it something like that? Oh, that's ugly. Um, It is source. I was right about that. Okay. Okay, and I think in the boot file, I only need to name the types, like basically do a pre-declaration. Okay. It can be given abstractly by omitting the equal sign. Yeah. Okay. So I think that's the trivial way to solve this problem. Um, my AST will import a source version of name that only defines what is required for this, which is the fact that there is a thing called name. And here, name will have a boot version. That will just have a data name. And that should, as a result, allow this to import the AST because name is no longer imported by the AST. It is the boot file that is here to prevent the circular import. Okay. The boot file was fine. That's good. Okay, what is wrong here? Oh, because I don't have equality for the function archetype resolved. That's peculiar. I should. Oh, no, because it's a type family within this, I think. Therefore, it will be known by that point, but it still must be a separate. What's the syntax again? Deriving instance. I guess I'm gonna do this by doing. Wait, that's incorrect. Wait. Huh? Just gonna put it in the capture group. Deriving instance. Why does it show me that twice? That is peculiar. Oh, because it's capitalizing based on the. Okay, that's annoying. I'm just gonna have to do that. I think that's all I need to do at this point. Aha. The problem was not the deriving instance. The problem is that function archetype doesn't have. That's the problem. I understand. Yes, it can trivially have one because path info already has one, so I just need the equal constraints. And I align that so that it reads nicely, which are already the same that I have for, if I remember correctly, path info. Yep, I even have the order constraints that I might actually add back to function archetype. There we go. Which means that here, name, that should work. Duplicate instance declaration. That's because this is supposed to read function archetype. And I wonder if, as a result, I can go back here to this. Aha, no instance for hashable. That makes sense, and I'm using the hash names as, but that should be fine because I think path info is, and function archetype is nothing but a tiny bit of more on top of a path info. So yep, I will just need to add that. Deriving generic here so that I can then use the generic instance of hashable for a function archetype. Okay. The AST compiles, the name file compiles. We've solved our circular dependency without having to introduce weird hash maps that we have to look up into on the side. We're just using normal names. And now context fun args no longer exists. That's correct. We've removed it. That'd be on the air. That'd be nice. Import tokens is redundant. Huh. I suppose because that was the only place where we had identifiers? Yeah, probably. I still should at some point introduce a new module for identifiers. They're still at this point declared as part of the tokens, which is not technically wrong, but still feels slightly wrong to import the tokens at this stage of the process just to have access to the identifiers. Error not a value doesn't exist. I thought. Oh, that's because it's not a capital V. Error not a type. Doesn't get the right arguments. What does error not a type expect a path and a name? Well, that looks like an original path and the path name to me. Oh, but I'm just giving a diagnostic. That's not correct. That's not correct. I should do a report error of that diagnostic. There we go. Okay, perfect. We don't have a lot yet. I don't know. I don't know if we have enough to try. We almost have enough, I think. Because with what we have cast and path. Everything else will just crash. But is that enough to actually test functions? And I think if we just finish return, then we can try to test some basic functions. So let's do that. Statement, return statement. I think that's already done. We traverse the expression that is associated with the return if there is one in the first place. If there is none, we assume that the return is a unit type, as in we're returning unit as in no value for this function. We look at the function return type. If it's not the same, we emit an error, and otherwise we emit a return statement. Return exists, which means we should be able to, at the very least, try some very basic things. There we go. Here's our test file with all of the constants and the weird type resolution and the thing we did 2 weeks ago where we were trying like nested types with type arguments and we have our placeholders and all that. Now, here, I might just comment all this out. Because in lieu of tests for the moment, we have some manual testing. In theory, if everything we've done this evening works, if I declare a function foo that returns an int, and it contains return red as car, for instance, that should not compile because the type of this return should be incompatible with the type of the function. And we support casts and names. So I think that's basically all about. I guess I could also add a const foo, which is an int, which is 42 here. So we can try things with constant as well, because constant enum, that's, I think, basically all we have access to. Oh, and function arguments as well. Did I do? No, we haven't done addition or anything like this. Okay. So I guess, let's say b, which is a boolean, is a function argument. So for now, this function ignores its argument and returns red as a character, which is wrong. Let's try that to at the very least check that none of the things required to try this are missing. This does not crash. It gives me a compilation error that is absolutely unreadable at the moment because we have done zero work for proper displaying of errors. Oh, multiple declaration foo. Yeah, of course I have the function foo and the constant foo. That's a yep, I'm gonna call it that. Okay, this compiles. That I was not expecting. That's bad news. Okay, so we have this function foo, which is indeed a function declaration. Has an argument b by value, which is a boolean. And the function type is returning a built-in type int. And a function body is a return statement of a typed expression of type int. Huh. As if the cast had been ignored. As if the cast had been ignored altogether. Is it because we have entered a case here? So we're casting from an enum to a character. So we should be in this case here. There is a source enum, but there's no target enum. Huh. I think this is just simply wrong, yeah. This is just wrong. This is saying I am casting to something that is a character, and I have found that I have an int literal, something that is known at compile time, as my value. Therefore, return an int expression. No, that's not correct. This must return a character expression where I will transform this into the corresponding character. And here, this is the type expression character type. Yes, I probably copy-pasted this and did not fix it afterwards. Here, I only care about int literal expression because if I have an enum as the source, I will only know, like, this is basically, do I know the enum value at compile time? This is what I'm testing. If I do, I can try resolving this. And otherwise, I have to do this. Okay. Now let's just do a quick check that the other cases of the casts are not wrong. I don't see a mistake of the types here. I don't see a mistake of the types here. And here I am saying Boolean expression for the Booleans and so on. Okay. So now I'm expecting this to not compile. It doesn't compile. Error wrong type, because we have something that is of type int, but we were expecting something of type character. Sorry, the other way around. Expecting an int, and we have something of type character. So if instead I cast this back to an int, this should now compile, and with expression like constant unfolding, this should already just be a return of the direct thing. So this function foo that returns an int, its body is a return statement and nothing else, and it returns a typed expression of type int, which is just the int literal 0, because that's the cast of red. I don't think I have a way at the moment to return some. No, I do actually. I do. I can try returning Boolean, that Boolean be as int, basically. And that will not be a value known at compile time. So I should still have that cast. Should I still have that cast? Yes, I should still have that cast. What did I decide? I don't remember, because there is an argument to be made that actually, even for things like casting to Boolean that cannot fail, casting from int to Boolean is a total function, it will always succeed. I might want to leave the cast there, because I might still want to introduce things that like shrink it to 0 and 1, basically. Because for some of the ways I'm going to implement ifs in actual Pete, having actual 0 or 1 is going to be important. That being said, I can do it as part of the if code generation rather than as part of the Boolean value thing. But let's see what I've decided here. I seem to have decided that no, I am not going to be doing. I'm not going to keep the cast. I'm just going to let the value be whatever it is. That means as a result, I am moving the responsibility of handling values that are not Boolean values that are not 1 or 0 to whatever constructs of the target language require that. I might simply, when it comes time to implement some of my code generation, basically make all of the ifs do a not on the value, and therefore any non-zero becomes 0, 0 becomes 1, and that solves the problem, I think. Which, do I already do that in my if blocks? Maybe I already do that. This would be in the assembly. Because in my bytecode for the instructions, I don't really have an if. I have just the entrance and branch and return. I guess I'll just have to translate the if. My code generation phase will have to translate all of the ifs into something that puts a not there, I suppose. Especially, yeah, probably. Especially since I will want anyway to optimize for which branch continues, which branch jumps. So that's something that's going to be dealt with at code generation time anyway. I think that's fine. Therefore, if we go back to this, the cast will no longer be there, but I am not able to have the full value at compile time because it depends on a variable b which is not known at compile time. So I should be seeing that this compile because the type check, but this should be a return of a path expression with the name of the path being the variable b of type Boolean, but in an in context. Yes, that should be that. Okay, so it's compiled. That's good news. Foo is indeed a function declaration. It has a resolved form. Function argument a by value b, which is a Boolean. Type is indeed an int. The body is a return statement that contains a typed expression of type int because the cast has happened, but the expression underneath is a path expression that points to the function argument b, which is a by value Boolean. Yeah, that's it. That's basically okay. So that works. Now, I guess we should be testing errors. Again, when I'm done with analysis, I'll write proper tests. This is just like, I don't have the means to test an actual function yet, so we're doing some manual tests. What happens if I try to return C instead? This should give me a name error. There is no such thing named C in scope. I have not written the name resolution functions this evening, but I wrote the resolve value that depends on the resolve name, which depends on resolve path, or vice versa. So that should still tell me that no C in scope. Error, name not found C. Perfect. With casts, what else can I try? I guess I could bring back one of my structs here. And I could say that the result of this function is an SO value, where x is 1 and y is 2. That I try to cast as an int. This should be rejected because at compile time I know that the type there is not castable to int. Aha, I hit an undefined. Ah, yes, that's because I haven't done struct expressions in I have not done struct expressions in functions yet. So that's not implemented yet. Okay. There's one last thing I want to try. There is something tricky we have started doing. I'm planning to like use a C++ like approach to generic functions, which is there is no trait. Therefore, there is no way when I go through a function to check that T type that is given as an argument, how am I using it? Is this use valid? Until the function gets instantiated, because each instantiation will have to result in a different function in the final binary, the final image anyway. Unless I can guarantee that they're always exactly the same sequence of instructions, I could try to deduplicate them. But unless I'm able to do that, yes, each instantiated function is gonna be a different function in the final binary. Therefore, what I need to do is I need to do a partial type check of generic functions, and when they are instantiated, I need to recheck them. I have not done the actual instantiation of functions yet, but as a result, I can still try what happens if my function foo that takes a t parameter takes a value of type t and returns it as a result of the function. This function will only work when, or actually I could just do as int, I guess. This will only work when it is called in a context where t is something that can be cast as int, which means when at some point in my code I do a foo of int, it will work. If I do a foo of character, it will work. And if I try at some point to do a foo of my s0 struct here, that will be a compile error. But at this stage, when I look at the declaration, I cannot know because I don't know what t is. So I should still be doing the name resolution, meaning I should be saying, hey, this b thing that happens to be a function argument that has a type which is the parameter t, but this type check of the result of the cast should then work because I bypass type checking when type parameters are involved because they will need to be redone when I instantiate functions. So this should compile if I haven't made a mistake. It compiles and it tells me that I have a parameter t indeed. The function argument b is a by value of a parameter t, and the type is indeed an int, and my function body is a return statement of type int because the cast has happened, but its value, the cast has not been inlined because I cannot resolve it to be true at this point, where the value is a type expression of type t, type parameter t, and the value is a path expression that points to the function argument b. Okay. And I want to check as well that if I remove this cast as int, the function itself does the comparison between this and this properly and therefore accepts it. Yep, perfect. The return expression, where's my return? Return statement is just an expression of type t and no longer of type int, but that's still type checked. Okay, perfect. Okay, so that's progress on functions. I'm feeling a tiny bit better, so let's continue a tiny bit longer. Sorry, let me just check whether this is urgent. Not urgent. I can answer that later. Okay. So now that we have done cast expression, path expression, what is next? I'm copying and pasting from the similar function that evolves, that evaluates, that resolves, that analyzes, the verb is important, expressions in the context of function, of constant declarations, and I just adapt them. So what if the expression we have is a field access expression? We have on the left some kind of expression, and we do a field access, a .x or something like this on it. This is going to have to be different, because in the case of a constant, I know the value of the struct at compile time. In the case of a function, I might not. So I still need to do this. I go recursively on the expression, which gives me a typed expression which with what I hope to be a struct type and a struct value. That means I should probably... Here, I can't just look at the struct value that I know must be a struct, I need to look at the type. Although I guess I could do the same thing here, which is like, if I happen to know the value of the struct at compile time, I can simplify this. I can do constant unfolding there again. Is that all? Because I suppose, let's go back to the AST. What I'm saying here is I have looked at the expression on the left-hand side of the dot of the field, and I have found a struct expression. And that is the type of the fields within it, a non-empty list of pair, identifier, and typed expression because we have already resolved the thing. I am somehow doubtful. Oh no, indeed, yeah, map second, which means I return a typed expression. Yeah, okay, I think that's correct. If I have on the left-hand side a constant struct expression that I know at compile time, I can go through the different fields and I can immediately replace this expression by the expression of the field, whatever it ends up being. And if I don't find a struct expression, this is where I have to handle the fact that like I will not know this value at compile time, therefore we have to do something different here. And here I am going to have to do I'm gonna have to resolve the type of this expression I got because I need to know that the type is a struct, even though I don't have a way to know what the value is yet. So that means I need to check, I need to resolve the type of that expression, and I need to check that it is indeed a structure that is in scope. Or like, oh, can I know that? Is that struct necessarily in scope? Could it be valid to have a field expression in which I am taking a field from a struct, but the struct declaration is not in scope? How could that happen? I don't think it's possible because I have no notion of private versus public. So if I have something that gives me a value of that struct, it must have access to that struct in the first place. No, it is possible. I have a first module that because I have selective imports. So no, I have a module that defines a struct and a function that returns the value of that struct. I have a second module that imports the first one, calls the function. The return type will be of that struct, but the declaration will not be in scope. Is that valid? Or can I just make the requirement that no, you're doing a field expression? For that, you need to know that the field exists, therefore it needs to be in scope, which would be reasonable. What does Rust do? If I have a mod private ish in which I have a struct that is not public who that contains an X, just an I64, and I have a function bar that is public that returns a foo. I think it's just going to tell me that like the visibility of foo exceeds. So that's not the test I should be doing. I should be doing it that way. I have this function bar that gives me a foo value, and that foo is going to be a very simple foo with where x is 42. And here in this module here, I'll have just a main here to test. I don't even need that. I'm just going to see if it compiles. I'm going to have some function baz. It doesn't matter the name. And here I'm going to use, I'm only importing the function in scope, not the type. So within this scope, bar exists, foo doesn't. Which means if I do an implemented here, and I do this, and I do type equals, oh, did I manage to level? Equals foo, this should not compile because foo is not in scope. Let's check this. Yep, foo is not in scope. Perfect. That means now that here in baz, I don't mention foo, but I do a simple print of a value. I'm just gonna say derive debug on this, which happens to be the result of bar dot x. So I'm taking the x field of bar, despite the fact that I don't have foo in scope, and therefore I can't check this against, like, will this work? Will this be accepted? What do you mean struct foo is never constructed? Oh, it's because it's never used. That compiles. That compiles. That is interesting. That means that the type check here, like, oh, this, when this type checks, foo isn't in scope, so it cannot refer to the declaration of foo. Therefore, it must refer. The value here, the return of this function carries enough information for the type checker to be like, you know, x is a valid field of this. If I did y here, that would of course not work because no field y on type foo, despite the fact that we know that in this scope, the type foo doesn't exist. Does that mean that I should annotate my typed expressions? I should annotate every expression I encounter when I do the resolving with a copy of the declaration of its corresponding type in case it's not in scope where it is used. I think that's the only logical conclusion. That doesn't seem too monstrous, but that might be some amount of work. Okay. For now, let's say undefined. Comment you out. Comment you out. Okay. So what I'm saying is, back to the AST, back to typed expression. Where are you? You are there. What I'm saying is here, I should be carrying around a copy of the declaration of the type of this value to be able to do analysis of it, even if it is not in scope. as we have established. Okay. This is gonna be a maybe of a declaration resolved. Maybe because something won't have declaration, some types won't. I'm still torn on this actually. Maybe I will want all of my built-in types to have a declaration as well, so I don't have to do special cases for built-in types. But if I do that, that means my declaration enum, which is also the result of the parsing, needs to contain a possible branch for built-in types, which will never be constructed as part of the parsing. I guess I could prune it by adding a phase parameter that happens to be void in the case of the parsed version of the AST, which means that branch cannot be represented as part of the output, in which case then I would not have dead branches in the AST. Things to think about. I haven't yet thought about what a built-in declaration would look like. But something, yeah, I'll have to think about this. For now, built-in types don't have declarations. This is going to be a maybe. This is going to break so many things. Let's see why it breaks. Immediately, cannot, oh god, yeah, oh god, that's already horrible. I have the ability to do the equal operation on typed expression, which is basically, do they have the same type? Do they have the same value? Why do I need this? I need this because I want to be able to compare names. I should probably simply change the way I do name comparison. Because for wait, that's not why I need this here, right? Because the function archetype is not. Where do I need the equality constraint on type exception again? What happens if I remove it? This is just to see where do I need it again. No instance for it indeed. Oh, for name. Rising from the second field of function argument. So the function archetype which contains a path info. Which contains a name type. I don't understand why this requires. I don't understand why this requires typed expression. How is that involved in this? Where does typed expression appear? It doesn't appear in any of this. Why is it required? Is it because I have done something silly and made my constraints I have said here indeed that I require an annotated expression to be comparable. Why have I done this? I don't know. If I change this, what is the result? Because if I can avoid having the equal comparison on type expression, all the better. Okay. Why am I doing EQ and ORD on expressions again? Why is this required? At some point I must be doing comparison like this, but I don't know why. When could I be doing expression comparison? Because type comparison, yes, of course. Okay. So far, I don't see errors about the missing equality constraint. That's good. That means we should be able to just remove those constraints that are not actually required. That's a lot of errors, but that's to be expected. Okay. So here, this is, I am creating a typed expression, and I am not including the declaration of the type in question. This is in resolve const value. That means I have found an enum. Perfect. Here I absolutely have the declaration. This is just, come on, just the declaration. I have it with me. Oh no. No, I think that's fine. Let me explain my own no. This particular thing, this function go here as part of my resolve functions that go look up a name in the scope and check like what actual thing is it associated with. Is it a function declaration? Is it like a type argument? What is that thing with that name in that scope? Is a type that is special, a resolve callback. And what it is basically the declaration it takes here as an argument that is given to a case. This declaration is either unresolved or resolved. I am writing only one function and it can be either, which means at this stage, I don't have a resolved declaration. And the reason for this is I want to be able to be like, okay, is this thing a struct? And it finds me structs that come from another module that has already been compiled, in which case I have a resolved declaration of the structure, or it is coming from this module, in which case the structure declaration has not potentially be resolved yet. And I don't want it to be resolved before I call this callback, because then I would probably end up in cycles. So what I have is instead I have this resolve declaration function that forces it to be resolved. If it was already resolved, that's a no op, and if it's not, calls it. And this like detects cycles and will prevent cycles in declarations. My point is that here, in this case, I think it's fine. I think it's fine because that means, oh, I need to attach the enum declaration of this value to the typed expression, which means I need to resolve the enum, and resolving an enum is basically a no-op. To the point that this might actually just, it's not going to compile, it's a wrong type. But I still have to do the resolve declaration thing and do a case on it. That's a bit annoying. That's a tiny bit annoying because I have therefore to have a internal compiler error path that I would like to minimize, but that's not the end of the world. Okay, so I can do it here at the top level because enums are always trivial to resolve, never gonna result in a cycle because they're just a list of names. which means I can do here resolve declaration of this thing, ignore the enum info, and in the case where after resolving I do indeed have an enum declaration with an enum info, then I can do all of that. And in the other case, this will be basically, I've tried to resolve an enum and I got something that's not an enum out and not an error that has been thrown. Internal compiler error that's never supposed to happen. This is basically unreachable. I will at some point have proper error handling for internal compiler errors that print a nice message, try to do a stack trace, try to do something that are a bit cleaner. For now, I haven't done any of this, so for now, that's just like error ice, basically. Okay, so at this point, I have resolved the declaration of the enum. I have, therefore, the declaration here, which is the enum info. And now I can I need to keep it in scope, I guess. No, I can just recreate it from this. Which means when I return a typed expression, the declaration I have to attach to it is just this one. Okay. It would be better, I think, if I were to introduce a name for it and then do a case. I should probably do it in this block. Okay. So the resolved declaration is the result of calling resolve declaration. That seems logical. And then I do a case on the result. Which remains the same. And now I can keep this value here for this. The upside of which is probably going to be reusing the same pointer underneath in practice, avoiding allocations. Okay. Perfect. That's one of many, many errors coming from the change we made to type expression. That's fine. I'm going to recompile since everything has changed. Okay. This is going to be true for all of those. But those are easy, I believe. Oh, they're not. I was going to say, oh, I'm in the case where there's no declaration associated with the thing I've looked up. Oh, but maybe I have to rethink. Let me think. So resolve value is the one I call when I have found something in an expression within a function that is a name. And I know I am not in the context of a function call, so this thing should not be a function. I am not in the context of a field access expression, so it doesn't need to be a struct. It is something that happens to have a value. So it is a constant, it is an enum, it is a function argument, it is a local variable. That's what it is. But in this case, I'm using my resolve functions that look at the things in scope and then look at their corresponding declarations. Do I have to change all of that? Do I have to change all of that logic because everything needs to be carrying its own declaration all the time? No, I don't think so. I don't think so. Only expressions need to carry it because the starting point of any expression will be a variable, will be a function, will be something where the name is present and therefore the thing can be looked up from the context. So I think only annotated expressions need to be carrying this. I think I don't need to change all of my resolve functions. Okay. However, here I am in the case where this expression I looked up, it's coming from a function argument. And because it's coming from a function argument, I don't have the declaration. That means I need to associate a declaration that means every name in scope, when I add the name in scope, I need to add also a pointer to the declaration of that thing. Like, oh, this variable was added to the scope, it has this type, which is declared there. Which will always be the case because to make a reference to the name of a type, I need to have its declaration somewhere. There might be some trickery where, like, if I import a type alias from another module, and it actually points to another type within the module that I did not actually import. But that just means, I think, that however I export a type alias out of a module, it needs to be pointing to the same declaration as the pointed type. Let me just check that. I'm adding stuff on top of the stack, but I think I need to check that the type alias declaration Yep, that's the problem. I have the problem there as well. I think there is one solution to this, and I don't like it. I think I have to change one very specific thing, and that's gonna be even worse than the change I'm currently trying to make compile. I think I have to remove this context declaration that points to the declarations of the things in scope. I think every declaration should be carried as part of the resolved information. Therefore, oops. Therefore, the name of something needs to contain the declaration. Because the name is the thing that uniquely identifies it, I guess. Or maybe, maybe I don't do that. because that would be monstrous. That means basically at every single step, I need to be carrying the full. I would need to be carrying the full declaration of the thing, which I guess would remove it from the typed expression. So there would be that. It would just be part of the type of everything that's being carried around. Like every type would be carrying around that's the associated declaration with the thing. Or could I? There is a better solution. There is a better solution. When I do a like a specific import of things out of another module, I am saying what identifiers are in scope that cannot be used. If I go back to the example of this, if I'm doing this, I am saying the identifier bar is in scope. The other things from the other module are not. That doesn't mean that my code can't look at all of the declarations in the top module and put them all in scope, which means, yes, sure, here, if in the code I type foo, that's a name that's not resolved, but as part of the type checking, if I look up foo, it exists. If I do that, then it's perfectly fine. It still works the way we expect. The name is not in scope. So the identifier is not in scope, but if I have the fully qualified name of that thing, I know where to go look for its declaration because I have taken it from the other module. In short, I only do the identifier to name part in the scope, but the name to declarations contains all of them, regardless of imports. If I do that, I don't have to do the change I was doing, where I have to have every single thing carry the declaration with it all the time. I think that's the right approach. Okay. So that means I can go back and make some changes. Oh, I should have committed before we started doing this. Because I can go back to typed expression and I can remove the declaration. Which means I can't easily do that here. I'll go back, do it back here. I can remove everything I've done here. The whole resolving the declaration, that's fine. That's no longer required. Which is good. It removes one more ice path. Okay. Perfect. Now, that means that I need to change I have resolved name in scope. That'll be fine. And that's enough. Okay. But that means I might need to do a second resolve struct. This one is for constants. This one is for based on a path. I need to find the current declaration. I'm going to have to do a second version of this function for when I have the name instead. Okay, that's fine. Now, there was something else I needed to change. First, I'm going to make this compile, because I've changed too many things. Then, I need to change the way I import things from other modules in the scope, because the declarations need to be there, even if the identifiers are not. Okay, that's good news. It looks like it mostly compiles. I have this go here that doesn't exist because it is indeed just analyze function expression. Aha, here's where I do equal on expression. Does that make sense? Because what this does, wait, why am I giving this as a function that takes to expression resolved? Does this make any sense? To define the entirety of this as equal. I guess for constants it does. Because for constants, I know what they are going to be. They are going to be int, characters, strings, and booleans, basically. I know why I've done it this way. I've done it this way because I've already done the type checking, so I know the types are the same. Therefore, doing a big case on the actual representation of the constant values would be extremely redundant. It's a lot easier to just like compare the things. I know they're the same underneath. I guess since I removed the type expression from the things, I suppose I can probably put this back. It's not very elegant to do the equal on the expressions, but it should be correct, which correct is more important than elegant, although both is better. Okay. What do we have here? Where do I have something named exp there? Oh, yes. Can I zoom this out a tiny bit? If it's too small, let me know. Okay. So this compiles, that's good. I'm gonna make a commit here before I make further changes. So what have we done? What can I isolate here? I can isolate this. We've made a change to the AST where we include the name as a boot file, and we've added a few instances. That stands on its own, which means I need to add this file as well, and I can add name here because what I've added, it probably won't compile on its own if I add this change as well. But I can probably include just the change. Okay. In here, in functions, where was it? It's at the top level. Result value. Oh, I've missed it. Somewhere in the analyze function, I do something different about the way I create the name of the function argument. Oh, there it is, right there. And now this commit will contain, we've made the AST import the name through a boot file, which is there and just contains data and name. Name now imports the AST and has changed function argument and has added let variable identifier. Those two things are why the AST requires more instances. And in the analysis, as part of this commit, the only change is we are creating the function argument with the proper argument. So that should compile on its own. What's the syntax I've used for my commit so far? Lowercase. Now, the second thing we've done is we've changed some of the resolution of. We've removed some of the contexts. I think I could, yeah, that's probably going to be an easy change there. Tokens is no longer required because the context fun args no longer exists, which means it's not initialized and it's not reset. Easy change, now that all of it goes. And I think here, what changes is this. And I think that's all because I think it was never used otherwise. Yep. Perfect. So I can commit this as well. Just gonna close this. We've removed putting the function arguments in a context fun args in the scope, and we've removed it from the monad. Okay. Then I think I'm just gonna commit all of the rest as There we go. So now that that's committed, oops, I can go back to what I was doing, which is I want to change. I want to change the way things are imported from other modules in the current scope, which is not init local names. That part is fine. It is this function that I really don't want to touch, but sadly, we have to rewrite it because I was making the assumption that I could just bundle the name of the thing that is imported with its declaration, because those would always be linked, and that's not the case. But that being said, it's probably going to be simpler. Because this function was doing two things. It was created for a given import. It was adding the hash map from name to declaration, adding things based on what we import, and returning the hash map from path, so like just raw texts, to the matching name. That first part is a lot easier because we don't need to filter the declarations anymore. We're adding all of them. Since names are guaranteed to be unique by construction, this means a lot of this goes away because context declaration that's correct will become just a thing of the module. Because that's a list of declarations right there. So I guess I just need to make a hash map from name to declaration for all of those, which is trivial. Wait, I'm completely wrong about this. This is the current module. This is the list of import, which means I have to look up into the hash map of module name to symbols. Okay. And symbols, what is symbol again? It is a hash map of identifier to with location. Okay. I could potentially make it a list of names. I should change the way I export things out of modules. It's not great at the moment. Yeah, I should change what I export out of modules because it's going to make my life a lot easier. We're doing the usual thing of one of those streams, which is like 3 hours into it, we're stacking things on top of the things we had stacked on top of the things we were doing. That's how it usually goes. Okay, so let's recap. In the process of doing the analysis of functions, type checking, name checking, I tackled what do we do in the case of expressions, and what do we do specifically in the case of a field access expression, where on the left-hand side I have something that must be a struct. I have realized that the problem is I need to have access to the declaration of that struct, because I need to check that the field that is being accessed in it is a valid field of that struct. But the declaration of that struct might not be its scope, because when I import things, I restrict which declarations I import for my inner thing based on the names I have imported, which is a mistake. So I have to redo the way I create my local context based on the things I import, so that when I say from that other module import the name foo, the identifier foo, then that identifier becomes part of the scope, but all of the declarations become part of the underlying hash map of declarations I have. So even if a name hasn't been imported and the user cannot use it, I can look up what the declaration for it is, so that I can resolve expressions. So we keep stacking. I have to rewrite the function that does the creation of the local context based on an import at the beginning of the processing of a module. Therefore, I want to change what I export from a module, because the thing I currently export from a module that has successfully been compiled is not extremely useful for the purpose of this. Okay. So, no changes. We are on a thing that compiles. Let's change everything. Let's create a small resolved module. That will contain everything that is exported out of a module. I already knew I needed more, because as I've mentioned earlier, with functions having generic parameters and not being instantiated until I know the argument at the call site, each module will need to maintain a list of its instantiated functions, even from its dependencies, kind of, again, how C++ does it, because I want to support incremental compilation. So we always knew we needed more than this basic symbols hash map, that we knew it was never enough. How do I change this? Do I want to make lenses for this? Would be nice to have lenses, but it should be fine as long as I don't use them in this file, because if I do, it makes all of the declaration kind of because I don't want to put that in the AST. It makes no sense. Could put that in the monad though. I'll think about it later. First, there's gonna be the names. And that's gonna be the same thing I have at the moment, which is a hash map from identifier to name. As in, at the top level, there is something that matches this identifier that is uniquely identified within the entire thing by this name, this thing that uniquely identifies it. Which means in my local scope, I can add this identifier points to that name. And of course, more than one identifier can point, like there can be more than one version of the identifier. That's already handled, but I need that. I also need, of course, the resolved declarations, which is a hash map from name to, well, with location declaration resolved. I keep the location information for the declaration because that's the only thing that's ever going to be needed location wise for error reporting purposes. Because the only reason I will ever need to go say, oh, from this other file is like, oh, this thing has already been declared in file bar at line whatever. And that's why I need the declaration still there. I might at some point, if the with location becomes a lot more complicated, maybe I'll instead change it to like just be a position or something. But for now, this is fine. And do I do now the list of like instantiated functions? Because what is this going to be? This is going to be the list of functions this is going to be basically because the declarations are only used for the purpose of type checking. Beyond the type checking phase, they're no longer needed. Each function just needs to know the name of the different things they're calling. The declarations are no longer required. Except they might be for some of the. No, that's not true. They might be for some of the code generation. But what the instantiations are going to be is going to be the set of all the functions that are included in the object file of the compiled module. It is going to be a hash map of name because not all of them will be from this module. If a module A imports a module B that has a generic function and A instantiates that function with int, it will need to contain a local instantiated copy of the function with an int parameter so that the linker afterwards can use that. Okay? But what is going to be the instantiated declaration of a function? Is it just the function info? I think it's just the function info. Okay, so that is what I am exporting out of a module. Okay, symbols no longer exist. So now we do change all of this. Because here, for each declaration at the top level, what I do is yeah, I know all of the names. It's not gonna be very, very special. Do I really need this hash map? Because it is trivially it's trivial for as long as because I know all of those names. Those names are going to very simply be top level declaration module name identifier. That's what they're going to be. So if I know the module name, I can reconstruct them all the time. There's no difficulty there. And I could instead look at the resolve declarations and deconstruct the name. The only problem is that it makes a bunch. I'm making assumptions about the shape that might prove to be wrong. Does that mean actually that what I had before, the symbols, was the right approach? This is redundant. Maybe it is enough. to just say I have associated to that identifier which is basically what I had with my symbols before. Hello, how are you? I think this is actually fine because I can always reconstruct the name from the identifier. It is guaranteed to be the same. I don't store the name that would have to like have a partial function out, and I can trivially reconstruct both informations. Partly. So the stack of things I'm doing this evening. I started with function analysis, so looking at the parsed function, trying to output a type check and name all the names resolved version of that function. I realized that I was doing expressions within functions. I was doing specifically the resolution of field access expressions, which means I have something that is a structure on the left and a field on the right, and I have to check that this is valid, that the names are valid. I realized that to check the validity of this, I needed to have access to the declaration of the struct that is the type of the expression on the left-hand side. But I realized that I have made a mistake in the way I resolve my imports, which is that I only import the declarations of types if that type name is imported in the scope, which is not correct. So I have to redo the way I initialize the scope of my current module based on what is imported from others. And as a result, I am stacking on top of it, changing what I export from a finished module. And I end up with basically the same thing I had before, but at least I have arrived at the conclusion that it was correct rather than just it being written down once and not thought out about much. So analyzing a module gives me this maybe resolved module. Nothing here changes. The symbols are gonna be a hash map of identifier to with location resolved declaration. I am gonna therefore, there's some tricky stuff there for sure. And so here at the end, we re-export a resolved module and not just a hash map with those symbols, which is the declarations. And for now, because I have not done an instantiation logic at all, just an empty hash map. Okay, so that hasn't changed, which means I need to rewrite this function, and that stresses me out a tiny bit. But it is in fact going to be a tiny bit simpler, because what I was doing was constructing a hash map from module name, which is the thing I'm importing from, to a hash map from the path, so what identifier, qualified or not, to a non-empty list of corresponding things and their declarations that I could then merge afterwards in a series of merge with the different levels of hash map that do the correct duplication when needed and reject with an error with duplication when needed. I can simplify this because this known symbols thing does not require excuse me, does not require carrying the declaration anymore, because declarations are gonna be separate. So now, for each module name, I'll have a hash map from path to an empty name. I can therefore, if I have more than one import of the same module, I can combine those by combine the inner hash map by not concatenating the non-empty lists, because by definition within the same module they're gonna point to the same name, And then across modules, I can combine the paths with concatenation so that if a path happens more than once, it will point to the different names in the different modules. Okay. But since I do this within my monad, I can remove this from here and put it somewhere around here. So for each import, look up the symbols of that import in the hash map here. I'm gonna copy paste this here for now. Except symbols doesn't exist anymore. This is a resolved module. And so this gonna be it's just going to be the resolved module, except I'm going to do a resolved module like this so I can decompose what's in it and have access directly to the resolved, I think I've called them declarations. Okay. Right there. With those, what can I do? I can already create, I can add all of the declarations to my context because I need to have all of them in scope regardless of... Fuck, that doesn't work. I just found a counterexample, I think. I think my approach where instead of carrying the declarations in scope, every expression carries its own declaration was the thing I tried and then went back on was in fact the right approach. Because A could be importing a module B, which imports a module C. And if I wanted to do this approach where I have all of the declarations in scope, I would need for A to know about the declarations of C, even if A doesn't import C directly. I would need to have like all the transitive declarations in scope. And I don't know if I can do that. Would it be simpler? Would it be simpler to do that, to have the transitive declarations? And the way that would work is basically every resolved module there, on top of its own declarations, would also contain all of the declarations of its dependencies. Full, complete hash map of all declarations. That sounds horrible. But the other option, and that's an ugly one, is that instead every expression, everything that carries around an expression needs to carry around a way to get to the declaration. Because otherwise, if I have a module A that declares a struct and a function that returns that struct, and a module B that imports only the function, not the that imports them and makes a function that returns a thing of the struct, and then a module C that imports B and use that function. I want to be able to check that the fields of the struct, despite not having the declaration of the struct, which happens all the way 2 modules away. So either I need to have all the transitive declarations of my dependencies, or I need every single expression to carry around a pointer to the corresponding declaration of the type of its value. Which would just be one more pointer. It's not the end of the world, and it's probably a lot easier than keeping a gigantic hash map and having to keep going through dependencies of dependencies. What would this look like, basically? It would probably look like this. Yep, yeah. Having it instead of having this gigantic hash map, I think is a lot better. But it's still. It could even just be that, because the identifier is part of the declaration anyway. Built-in type, built-in function will require something anyway. But as a result, it doesn't have to be a declaration. It can be a very simple other thing. And type parameter. What do I do for type parameter? It will be a maybe declaration resolved, because either it is a type that has a declaration and therefore it has one, or it is a built-in type and it doesn't. Placeholders don't. The function argument doesn't need to have one, because its function argument type contains the type, which contains the name of the type, which will point to the declaration. So that's fine. Same goes for the let variable binding. So I think this change is enough. Where it's going to be a nightmare, however, is that I've added an EQ instance to this. Which means now my declaration type needs to have an EQ instance. Or maybe I don't. Maybe I don't, and instead I do a much simpler. Yeah, that's the thing I'm thinking. I think it made sense when the type name was a lot smaller, but now that it is a lot more complicated and it carries around the declaration, I think this has to change. But I also think I've been at this for 3 hours and a half. I think this is the right approach. I think this is going to make a lot of things simpler, but it also means I'm going to have to rewrite half my analysis module, because a lot of it is based on the idea right now that I am collecting, that I have this indirection between identifier and names, and then from names to declarations. That second half no longer exists. Oh god, I have another problem. I have another problem. Which is, it's probably gonna be fine. I have at the moment a way to resolve names and declarations that is built to avoid cycles. And the way it is done is I can look up a name and then look up its corresponding declaration either within the resolved declarations that come from the things I have already analyzed or from imports, or the unresolved ones that come from the local module that have not been resolved yet. Because sometimes cycles can exist and they're fine. For instance, if I had pointers, I don't, but if I had pointers, a structure A can contain a pointer to structure B, and structure B can contain a pointer to structure A. Which means I need to do that kind of resolving the type of something without fully resolving the types, because otherwise I run into cycles. I have done all of this with two different hash maps, the resolved declarations and the unresolved ones, to be able to do this kind of like I try either, basically, with code that is able to switch on the fly. Here, all of them are resolved, because name is the resolved version. That might be a problem. That might be a problem. Because, yeah, that is immediately a problem. How do I initialize the names of my local declarations within my module? Because I don't have them resolved by the very definition of the fact that this is what my analysis phase is about. So, that means that I will have to keep doing the same thing I do now. And I need to keep, basically, when I do a name resolution, rather than looking through something that always points to a name, I need to point to something which is either this is the local one, or here's the name, which means I need to change all of my name resolution functions. That's doable. That's not the end of the world. I think it is the correct way forward and will simplify a lot of things down the line. But in the short term, there's a tiny bit annoying. Although I think I will need to keep the same declaration thing, because not every declaration will be within this. So I think I might need to keep the same logic that I have at the moment, which means some of my resolving functions will have to stay the same. Because a lot of the time I'm not... Yeah, actually, I think it's not that bad, because I think I can keep all of my resolution functions the same, because most of them will be about, I have this name in my scope, what is it? And that logic hasn't changed. If I have a name foo in scope and I want to know what it is, I have to look up its name, and therefore I have to look up its declaration. But yes, what has changed is that I will not necessarily have... Yeah, okay. I'm gonna stop here for this evening because I'm already been streaming for 3 hours and a half. But what I will prepare for next time for Thursday is basically, okay, we've explored a lot of possibilities this evening. The shape of this approach is the correct one, but it has a lot of limitations because of this distinction between resolved and not resolved yet. Therefore, I need to have a clear approach for next time for how I solve this, so that next time we can get started with this. Okay, that was a lot of progress this evening. That was fun. And yeah, on Thursday, we figure out declaration resolution and declaration in names. In the meantime, thank you for tuning in, and I'll see you on Thursday.